In this chapter, we're going to learn more details about the three major states of matter: solids, liquids, and gases. Kind of gives us an opportunity to take a step back from writing reactions, doing stoichiometry calculations, and again, revisit some of the general properties and characteristics of just matter in general. Nothing specific about elements or compounds, just a few connections there, but just keeping things pretty general. So in section 1, we're going to talk about gases. And the first thing that comes up in this section, actually all three sections, first section for gases, but then for liquids and solids, what's called the kinetic molecular theory. Now, if we just think about these first three words, kinetic, molecular, and then theory, we can kind of derive some things here. Kinetic, talk about motion or movement. So we're talking about the movement of molecules. Okay? So we're going to have 5 statements here that talk about how gases move, how gas molecules move. And these 5 statements are pretty straightforward. First of all, characteristic number 1 of gases. They are a large number of small particles spread relatively far apart compared to their size. So again, if we can imagine a gas in some type of a container, and you traditionally see 3 containers, solid, liquid, gas. Solid particles, they're all packed, jammed down in here tight. Liquid a little bit farther apart, but again, still kind of nice and small. And then gases, they are spread out all over the place. You may have learned 3 phrases kind of in the past. Solids have a definite volume and definite shape. Gases have a definite volume, indefinite shape. Gases have indefinite both, volume and shape. And we'll talk about that more later. Number 2, collisions between particles are elastic in energy and conserve. So we have conservation of energy here. When gas particles collide, basically what we're saying is there's no friction and there's no heat. Now, this is a theory. Obviously, there's always going to be a little bit of friction and a little bit of heat when they collide, but very minimal. Number 3, gas particles are in constant motion. So if we think about it, the gas molecules are always moving. All those atoms, those molecules are in constant motion, much more so than solids or liquids. Number 4, there's no attraction or repulsion among the particles. So again, if we're thinking about gases, there's no electrical, no magnetic interaction among those molecules. And the last thing, again, we're not going to do a calculation, but if we wanted to simply express, well, how much kinetic energy does a particular molecule have? It's simply 1/2 times mv squared. So 1/2 times the mass of the molecule times its velocity squared. Now, what's interesting about these 5 statements, we are going to revisit these a lot in this chapter. And they're going to be able to explain a lot of things and give us reasons to understand what we're learning. The thing that's kind of confusing here is we sort of go in a circle. One thing is related to the next and is related to the next and so on. So we find this continuous circle of how all of these properties and characteristics interact with each other. Okay, the next thing is in each one of these sections, they have several terms here, very similar for us to define whether it's a solid, liquid, or gas situation. We see these 5 words here: expansion, fluidity, low density, compressibility, diffusion, and effusion. So quite simply, we're just talking about how do these terms apply to gases. Well, what do we know about gases and expansion? They expand a lot. They will expand whatever to whatever size the container that they're in. You blow up a balloon, how the gas will continue to spread out as much as possible. Okay. A lot different than a water balloon, and we'll talk about that when we get into liquids. Fluidity, gases flow. Now, they kind of flow like a liquid. They're very fluid. At some point this chapter, we'll look at some dry ice, and we'll talk about how the carbon dioxide gas moves with that dry ice. Low density, gases have a very low density compared to liquids and solids. Compressibility, it's very easy to compress a gas. Imagine you take a balloon and you're able to squeeze it. You can squeeze a balloon into a smaller size. At some point, you reach that limit, but again, we can get to somewhat of a decreased size because we can compress that gas. The last two sometimes people use the words interchangeably. We really shouldn't. The terms diffusion and effusion. The term diffusion, okay, thinking dye, think two gases. It's really talking about the ability for how quickly two gases mix. And this could involve a reaction. At some point in class, show you a video, maybe even kind of will attempt to do it in class, although I have to use very concentrated chemicals. On one side, we're going to use concentrated hydrochloric acid, and on the other side, use concentrated ammonia. And what happens, these two gases reach the middle, and we have a reaction. The thing that's going to be interesting is the reaction does not occur in the middle. Right? The reaction occurs offset to the center. The reason for that, these gases are moving at a slightly different speed, therefore they're not going to mix right in the middle. Diffusion is just imagine a gas is escaping a container. Imagine we're in a room and we have some type of container. We open it up, and out comes, let's say we put ammonium sulfide, NH4, 2S. That is the chemical, the rotten egg smell. So imagine we have a container of ammonium sulfide. We open it up in the room. How long does it take until we smell it in the entire room? Now, that has a lot to do with other factors too, which at some point we'll probably talk about in class. So what you need to do is just feel comfortable with these 5 terms and to be able to explain how gases are affected by these 5 or what their characteristics are related to these 5 terms. The last thing we'll talk about is just does a gas have properties that fit exactly to the what's called the ideal gas law, or do they behave slightly less than ideal or slightly less than perfect? And the answer is, well, not all gases are theoretically going to follow those kinetic molecular theories to the letter. So here's what happens. Real gases, they don't always behave according to the kinetic molecular theory. When do we have to worry about that, or when does that start to break down? Quite simply, 2 situations. Is if we're dealing with high temperature high pressure or low temperature, that's when those gases behave less like a gas. Makes sense. If we have gas at a really, really high pressure, we're packing those molecules in to the point that it's almost like a solid. Also, low temperature. Well, low temperature means that they have a very low amount of kinetic energy. Well, if they have a low amount of kinetic energy, guess what? They're not moving around very much. Therefore, they're packed in pretty close. Therefore, less ideal. They're going to behave less like a gas at high pressures and low temperatures. So those 2 situations. Now, the third thing is really a property of the gas, what its bonds are. If a gas is very polar, it is not going to behave according to kinetic molecular theory. Why is that? Well, if it's something very polar, remember, we have an unequal attraction among the electrons. If we have an unequal attraction, that's going to affect the properties and characteristics. So which ones are ideal? Okay, well, once we start to get things that are nonpolar, okay, things like hydrogen gas and nitrogen gas are very nonpolar. Once we start getting into things like carbon dioxide, okay, it's a little bit heavier. We get into carbon monoxide, a little bit of oxygen gas has polar bonds to it or dipoles to it that can start to affect it. So we tend to have gases that are very stable, very nonpolar, that are going to behave more like the kinetic molecular theory. What we'll do in the other sections then, we'll kind of revisit some of these concepts in terms of the kinetic molecular theory and the 5 properties or characteristics like expansion and compressibility, see how they relate for solids and liquids also.